You might look at this function and think we need the quotient rule to take the derivative, and you wouldn't be wrong, but there's one problem. The answer choices are all in terms of sine and cosine, but this has tangents and secants in them, and it's going to be a giant mess of tangents and secants when I take that derivative using the quotient rule. So how do I get an answer? What you want to do first is simplify ahead of time. So we're going to rewrite tangent in terms of its constituent sines and cosines. The same for the secant down below. So I'm going to rewrite this as 1 over cosine down below, and the tangent's been rewritten as sine over cosine. By dividing by a fraction, we flip the bottom fraction and multiply, so times cosine of x over 1, that gets rid of this guy down below. And I'm going to distribute cosine to these two terms. And when I do so, cosine times sine over cosine, well, the cosines will cancel, just leaving me with 5 sine of x. And the cosine distributes to the negative 3, giving me negative 3 cosine of x. Now, you're not quite out of the woods. A lot of people stop there and think, oh, that's my answer. But remember, all we did there was simplify the expression. That didn't actually take the derivative. So for this next problem, we're going to take the derivative. The derivative of 5 sine of x is 5 cosine of x. And the derivative of cosine of x is positive, or like as negative 3 cosine of x becomes positive 3 sine of x. And that is your answer.